Hi, this is Miss Peace Corps, and I'm here to teach you how to write simple ionic nomenclatures. I'll have another video about ionic compounds that get a little bit hard to write. So this one's just a really easy intro. So the first thing is you need to be able to recognize when you have an ionic compound. So an ionic compound is going to be when you have something that has a positive charge and something that has a negative charge that are bound together through some type of bond, in this case, ionic bond. So your positive charge can come from a metal element or a polyatomic ion. The negative charge can come from either a nonmetal element or from a polyatomic ion that has a negative charge. So let's look at what happens with the charges if they end up being the same. So looking at LiCl, Li is lithium, and I don't have to write a Roman numeral 1 because lithium is in group 1A. All of your group 1A compounds have a positive 1 charge and there's no other variance, so it's just lithium. Chlorine is what Cl is. However, if you have a ionic compound that just has 2 elements, we're going to change the ending of our non-metal to end with IDE. So instead of chlorine, it becomes chloride. Simple. But if our second part, if the negative charge is polyatomic, like number 10, we know it's polyatomic because there are 3 different elements. 3 capital letters tell us it's 3 elements. So the first one is potassium, simple. Just like lithium, it only has a positive 1 charge, so I don't have to write potassium 1. NO2, on the other hand, is not nitrogen, oxygen. Instead, what it is something that I have to look on the back of my periodic table, look at my polyatomic ions list, and find NO2. NO2 has a negative 1 charge and is called nitrite. Now, with polyatomic ions, we leave the ending alone. It is called nitrite, and it stays nitrite. So what if we have the name and we need to go to formula? So let's look at number 13. Sodium has a positive 1 charge, and it always will. Nitrate is NO3 with a negative 1 charge. What we do with the charges is we try to get them to cancel out. So plus 1 cancels out negative 1. So the formula for sodium nitrate is NaNO3. You don't ever look at the subscripts whenever you're trying to cancel out charges, just the superscript charges. That's what we're looking for with canceling out. You could also have something that is binary. Looking at number 17, potassium has a positive charge of 1. Iodide has a negative 1 charge. Put them together, it's just Ki. Those charges cancel out. You can also have it whenever the charges are more than just 1. So look at number 21. Be is beryllium. I'm probably spelling this wrong, but it's okay. Beryllium, and it is in group 2A. All of the elements in group 2A have a 2 positive charge, so I don't have to write beryllium 2, just regular beryllium. Oxygen is a nonmetal, but it's binded to a metal, so we're going to change the ending to IDE. So it becomes beryllium oxide. Then you can have something like number 24. There's Ca, which is calcium. Always has a 2 positive charge, so no Roman numerals. SO3 is something that I'd have to look on my polyatomic ions list and find. SO3 is going to be sulfite. And I never change the endings on my polyatomic ions. Then last but not least, if I have the formula and I go to the name, I look at the charges. Calcium has a 2 positive charge. Oxide is oxygen, has a 2 negative charge. They cancel out. It's CaO. Calcium dichromate, Ca2 plus, Cr2O7, 2 negative. Remember, I'm just looking at the charges, which are superscript, and I'm canceling them out. So it's CaCr2O7, the formula for calcium dichromate. Woo, we did it. Awesome.